Hello, you're welcome back. All right, so we are going to continue from where we stopped. Now we are going to be solving some questions. Here I'm going to show you the application of a property table. Now let's start with the very first question right here. Okay, so the question goes this way. Okay, so a rigid tank contains 50 kg of saturated liquid water at 90 degrees Celsius. Determine the pressure in the tank and the volume of the tank. Okay, so you know very well that the pressure we are looking at, all right, we read it from the property table. So that simply means that we are going to use the temperature to find the pressure. Okay, now for us to get the volume of the tank, okay, let me solve the first one first. Let me solve this one. So let's go straight to the property table. I'll go straight to property table. Hopefully you will see this. Okay, we'll have the property table for English unit, we'll have for the SI unit. Now the temperature that was given to us is actually in SI unit, that's 90 degrees Celsius. Okay, so let's see what we have. So we'll go straight look at the property table for saturated water. All right, so we'll go to 90 degrees. So the pressure in the column is 70.183. So the saturated uh, vapor pressure is 70.183 and it's measured in kilopascal. Alright, then number 2, we are being asked to calculate the volume of the tank. Okay, the volume of the tank is the total volume. We are going to read the specific volume from the property table. Alright, now mind you, specific volume is given as volume per unit mass, total volume per unit mass. You know the formula since we are looking for the entire volume of the tank. Okay, so the volume of the tank, or the volume of the tank, which of course is the volume of the liquid, saturated liquid, is going to be mass multiplied by the specific volume. The mass is given already, it is 50, then times the specific volume. So let's go read the specific volume from the property table. So this is the volume column. So at 90, this volume is 0.001036 and is measured, okay, 0.0010, that's a cm cube, right? Okay, so 0.001036. That should be meter cube, please pardon me. 0.001036 in meters cube. Okay, so if we multiply this, let's multiply what we have. Okay, let me get a calculator. So this is going to be, of course, 50 times 0.001036. So that's 0.0518 meters cube. 0.00, okay, 518. So if you want to convert this to centimeters, centimeters cube, multiply by 1000, that should be 51.8 centimeters square. Alright, so I hope that is well understood. Now let's look at another one. So this is another example. A piston cylinder device contains 20 feet cube. So this unit is not SI unit. This is English unit. So we are going to read it from the English unit table. Okay, remember the table has English unit. That's a table for English unit, and that's one for SI unit. Okay, so I hope that is well understood. All right, so here is the volume. All right, a piston cylinder device. All right, and the pressure is 50 psia. Now determine the temperature. So we're going to go to the pressure table of this saturated water. All right, okay, then we read the temperature. So solution. So the very first thing we're asked to evaluate is the temperature. Let's go there. So this is the table. Okay, no, this is not the English. Okay, here is the English. As you can see, this is the English unit. The pressure is in psia. So the pressure that we are looking at is 50 psia. Let's go there. So 50 psia, the temperature, this is the pressure column, right? So the temperature is 280.99 degree Fahrenheit. All right, so here we go. So Tsat to what was that again? 280.99. Okay, so 280.99 degree Fahrenheit. Okay, so number 2. All right, we are to determine the mass. Remember, specific volume is equal to total volume divided by mass. All right, specific volume is equal to total volume divided by the mass. So invariably now, mass is going to be equal to, if I make it the subject, total volume all over the specific volume. Total volume is given here. Then we'll have to read the specific volume from the property table. Let's go to the property table, then we'll now go to the specific volume column. Okay, so VF at 50 psia is 0.011727. Okay, so this is gonna be 2 feet cube all over 0.0, okay, 0.00, okay, what was that again that I read? 0.001727, okay, yeah. Okay, so 2 divided by 0.0, okay, all right, okay, yeah, 1727. Let's see what we have. 11 what? 115. Okay, but this is English. Okay, mass is always measured in allobium, right? Okay. All right. Let's get another question. So this is another example. Here we go. A mass of 200 grams, okay, of saturated liquid water is completely vaporized. So this is completely vaporized. Okay, take note of this. It is completely vaporized. That means from the graph now, okay, from the graph now, what you are looking at is it's not just, okay. So from the graph, look at what we are looking at. So we are looking at saturated vapor, because it's completely vaporized. Completely vaporized. Okay, this is saturated liquid. You know that already. Saturated liquid. Okay. So, and the pressure for that is 100 kPa. That's English unit. Now don't forget that at this point, what we have here, the specific volume is Vf. At this point, the specific volume is Vg. Okay, so between this point and this point, there's the difference. So Vfg is equal to Vf minus Vg. That's the difference between when you at in between, okay? Once it is in between. Alright, so let's just go straight to what we are looking for. So what are we looking for? A part of the question, the volume change. So the volume change is the VFG. We read it from the property table, which is VFG, alright? But the volume change is given as VFG, don't forget, which is VF minus VG. The volume of the saturated liquid, okay, then minus the volume of the vapor that is actually formed. Okay, so change in volume, okay, is VFG. Okay, so let's go straight to the table. We'll go to the English. All right, so here we go. The pressure. Okay, so what you're going to be using is the pressure. Is the pressure table, not the temperature. So we'll go to the pressure table. So we'll go down. This is the temperature. All right, so here is the pressure table in English. So the pressure we are looking at is 100 kilopascal. So here we go, 100 kilopascal. So this is the temperature, but I'm going straight to the volume of the saturated liquid and the volume of the saturated vapor. So their difference is going to be this is equal to the change in volume. Okay, don't forget. All right, the change in volume, and not forget that we have to multiply by the mass. But first of all, let's calculate the VFG. Okay, so VFG is giving us VF minus VG. All right, so let's read it. VF at that at 100 is 0.001043. 0.001043 minus Vg at that same pressure, Okay, so which of course is 1.6941. Okay, 1.6941. Okay, so now in this case, I will, since this is actually is a saturated vapor, so what you have is more of vapor. So instead of doing VFG, I will do VGF, because what we have is more of saturated vapor. So I have to this VGF. Okay, so I have to turn it around. If what you have is more of a liquid, saturated liquid, I would have done VFG, but this is saturated vapor. Okay, so we have the liquid, all right, at that temperature, at that pressure, please pardon me, the liquid at that pressure is less than the vapor, so invariably that should be instead VG minus VF. Okay, so the other way around, what I'm supposed to have is 1.6941 minus 0.001043. Okay, so this is how it's supposed to be. So it's supposed to be like this. All right. Okay, so let me write it right here. 1.6941 minus 0.001043. Okay, so let's do that subtraction. 1.6941 minus 0.001043. Okay, so what we have is 1.693057. Okay, 1.693047. Now remember, this is specific, VGF specific. All right. Okay, so now for you to get the total volume, remember specific volume VGF is equal to the total volume divided by mass. So the total volume, so it's going to be equal to mass, okay, multiplied by VGF. So let's look at what we have as the mass. The mass is 200 grams. So this 200 grams are converted to kilogram by dividing by 1000. That will be 0.2. 200 divided by 1000 is 0.2. Then of course multiply by 1.693047. Okay, so let's do that multiplication. So at the end of the day, you have what you're having is 0.3386 approximately. 0.3386, and that will be in meters cube. Okay, so I hope that is well understood. All right, so that is it for this video. In the next video we are looking at more. So see you in the next video. Thank you very much.